Welcome to this Pandas documentation video series. Today we want to look at how to calculate summary statistics in Pandas. And for us to do this, we would use the Titanic data set. And I think I'll go ahead here to File, New Notebook in Drive. Same thing we've been doing over and over. Come here, rename the file, calculate summary statistics. Calculate summary statistics. I'll mount the drive. Again, this is the same thing we've been doing over and over, right? I'll mount the drive and wait for the drive to get loaded here. While the drive is doing its own thing, I'm going to import pandas as PD. That is something we already know about. Now, because we will use the Titanic data set, I need to copy the path. I have it stored here in data. So I'll go to titanic.csv, 3 arrows, I'll copy path. Come here. I can close this out now and zoom in a little bit so that you can see what I'm typing. I will do Titanic equal to pd.read_csv. I'll paste that path I just copied now, and that should be the CSV file. I'll go ahead to investigate the first 5 rows, and this is what I see. Let me zoom out a bit so that we can see the data set in one glance. So we're done with this. Now what we want to do today, and I'll just give a heading here, is how to calculate summary statistics. All right, so the first thing we want to look at is the aggregating statistics. And you'll see what this means in a moment. Statistics. Okay. So let's say we want to know the average. Again, what is the average age of the Titanic passengers? Now, this is a question we want to know. What is the average age? What is the average age of Titanic passengers? Now, for this, again, recall what we've been saying. What column do we need here? The age, right? And so we pick the age, Titanic age. What do we want to do? What is average? And so this is one of those aggregating statistics where we have a measure called mean, and that's a method here. It's a function that enables us to get the mean. So if we run this, we have the mean age, which returns that 29.69 or 29.7 if we approximate that to 1 decimal point. There are different statistics that are available, and you can apply them to columns with numerical data. Now, but operations in general exclude missing data, and they operate across rows by default. And let me say that again so you know. By default, missing data are excluded. And these operations, like this mean, median, mode, and so on and so forth, they operate across rows by default. Let's say we want to know what is the median age and ticket fare price of the Titanic passengers, right? How do we go about this? Now we have two different things, median age and then the ticket fare price. For the ticket fare price, we use the fare column, which is this we have here, the fare. That's the ticket fare price. So how do we do this? So again, we want to calculate the median age and the median ticket fare price of the passengers. Now, the way we'll do that is, you still remember how we can select 2 columns. In this case, we do Titanic with a square bracket and another square bracket because we have more than one column we want to select now. And so we select age first, and then a comma, and we also select the fair, which is this here. And so this will return to us the age and the fair. Now we can then calculate the median of these two columns. And if we run this, we have the age, the median age is 28, the median fair is 14.45. Now, the statistic applied to multiple columns of a data frame, the selection of two columns returns a data frame. I think I've mentioned this. Once it's more than one column, it's no longer a series. It's now a data frame. And this is done for each numeric column. And again, recall that we said this is done row-wise, right? Now, the aggregating statistic can be calculated for multiple columns at the same time. Now, if you remember the describe function, so we can use the describe function in this case. So let's say we want to know, just the general statistics, not only the mean, the median. We want to know the standard deviation. We want to know the count, and so on and so forth. We can do this Titanic, and again, because we have more than one thing, we pass that in. It has added one more for me, which I do not want. And I can have here .describe. Once I do this, now you can see what we have here. This is the maximum age. This is the maximum fair. This is the number of fairs, the number of, so we have like 714 data collected that have age. So there are some missing data here. But instead of this predefined statistic, specific combinations of aggregating statistic for given columns can be defined by using the dataframe.ag method. And what that means is that rather than just have all these, for us at once, say we don't want everything. We don't want, for instance, we don't want the 25% percentile. We don't want the 50%, the 75%. We just want specific statistic. We can then use the ag method. And how we do that is by calling the titanic.agg, which is, of course, to help us with the aggregating statistics. We can then pass in this, which is, of course, a dictionary, where we then pass in those statistics we want to get. So we want the mean for the age, we want the max for the age, we want the median, and we also want the skew. All right, for the fair, we want the mean, we want the max, we want the median, but in this case, we want the mean. So this is how you can specify the aggregating statistic you want, right? And so if I run this now, you can see we now have the age with skew, because we specify that we want skew for age, but we don't have anything under the mean because we didn't specify that we want mean. If indeed I include mean here and I run this cell again, now you can see the mean here in the output. So let's see, how can we then say we want to talk about aggregating statistics grouped by category. So let's say we want to know the average, and for this, just so you know, we want to know the average age for male versus female Titanic passengers. Right? How do we go about this? Now again, look at what's happening here. We have the age, right? That's the main thing we want to know, right? But how do we know the male versus female? What column gives us that information? Let's quickly run head, which I will comment out here. I'll do Titanic.head just so that we can see what we have here. If you look at the sex column, we have male, female, and that's the column that tells us if the person is male, if the person is, or if the person is female. And so we know that we now need two different columns, right? We need the age, which is what we want to know, the average age, but we also need the sex, right? That's how we can differentiate between male and female. So how do we put all these together? So the way to do that is we'll call the Titanic again, and we'll have these two columns. We want to select the sex, but we also want to select the age as well. But this time around, what we want to do is that we want to group by the sex. And we want to calculate the mean of whatever we have there. And so let me just break this down. Our interest is the average age of each gender. Now, a subselection of these two columns is made first. So the first thing we do is to make a subselection on these two columns, right? And once we're done with that, the next thing is to group by. And so we take that group by method, which we see here, we apply it on the sex column, because that's the category that we want to group by. And so we take that, we apply it on the sex column to make a group per category. And so the average age for each gender is calculated and returned. And so if we run this, what we have is this. And so the average age for females is 27.9. The average age for males is 30.7. Now, calculating a given statistic, whether it's, for instance, the mean age for each category in a column. So, for instance, sex is a common pattern that you would regularly see in questions that have to do with data analysis. But the group by method is used to support this type of operations. And this is because it fits in the more general split, apply, combine pattern. And so the first thing is you split the data into groups, you apply a function to each group independently, and then you combine the results into a data structure. Let me say that again. You split the data into groups, you apply a function to each group independently, and then you combine the result into a data structure. And that's exactly what you see here. It's split, apply, combine. You split first, we first split. This whole thing does the splitting for us. We apply the mean function to it, and that does it individually, group independently. It does it for each group independently, and then it combines the result into data structure, which we then have here. Now, the apply and combine steps are typically done together in Pandas. And as you see in the previous example, we explicitly selected the two columns first. If not, the mean method is applied to each column containing numerical columns by passing numeric only equal true. And so if we do something like Titanic.groupby, and we pass in sex here, we say dot mean and we say numeric only equal to true. If we do this, let's see what we have here. As you can see, we have the female, we have the male. So we are grouping the entire data set, and we are calculating the mean. We are picking out only the numeric columns. The fair is numeric. As you can see, we don't have name here because name is not numeric, right? And so it doesn't make sense to get the average value of the class of that passenger. But if we are only interested in the average age of each gender, the selection of columns, that's the square bracket, is supported on the group by data as well. And how that works is this. So we can have Titanic.groupby, and we pass in sex here. But instead of us, we just want the age. All we want is just the mean age, right? We can do something like this, age, and then we do dot mean. If we run this, we have this same result that we have here. So you can write it like this, or you can also do it like this. Now, of course, the P class also contains, the P class column contains numerical data, but actually represents 3 categories or factors. And so you won't want to treat the P class, for instance, like it's a numeric category. No, it's not. It's actually a categorical variable. It's a column that has to do with categorical variables. And those variables are respectively 1, 2, and 3. And so calculating the statistics on those does not make much sense. So in Pandas, we have a categorical data type to handle this type of data. And we'll look at this in another section where we'll talk about categorical data. But for now, let's continue with this. Let's say we want to know the mean ticket fare price for each of the sex and cabin class combinations. So how do we go about this? Look at this. We have the ticket fare price, we have sex, we have cabin class. I would say always take note of what you need. What are we looking for? The mean ticket fare price. What do we want to get for each of the sex and cabin class combinations? What we need is the mean ticket fare price. How do we go about this? So we can say Titanic.groupby. We pass that in. But what we need here is the sex, right? We want to group by the sex, and we also want to group by the class of that passenger combined together. But what we want to do is the fare. That's what we actually need, right? And then we can say dot mean. And so this will give us this. So for females in class 1, the average fare, that's the mean ticket fare, is 106. For class 3, the mean ticket fare is 16. For male, the mean ticket price is 12. So grouping can be done by multiple columns at the same time. You only provide the column names as a list to the group by method, right? Just as we did here. You provide the column names to the group by method. That's for the groups that you want to know. Now let's say we want to count number of records by category. And that's what we want to devote this to. And the question we want to ask ourselves here is, what is the number of passengers? Passengers in each of the cabin classes. What's the number of passengers in each of the cabin classes? And now, as you can see, we have two different things, right? The number of passengers, right? But in each cabin classes. So you'll agree with me that all we need is just the cabin class, right? Because the number of passengers definitely, as we look at the cabin classes, each of those cabin class comprises a passenger. So how do we do this? We do Titanic, we look at the P class, then we use value counts. So the value count method counts the number of records for each category in a column. And so if we do this, we have those in class 3 are 491, those in class 1 are 216, and those in class 2 are 184. Now the function is a shortcut, as it is actually a group by operation in combination with counting of the number of records within each group. So we can also use the count method, right? It's a function. But this value count, now I'll show you what that looks like. We have the Titanic dot group by, we have P class here, and then we're selecting that P class again, dot count. So essentially this is actually what's happening here. So when we run this, we get the same result as what we had here, except that this orders it by, as you can see, the result count here from in descending order, while this orders it according to the P class. So both size and count can be used in combination with group by. Whereas size includes NaN, that's the values that are missing. It includes the missing values and just provides the number of rows, size of a table. Count excludes the missing values, and it's very important that you note this difference. So we can use size, we can use count. So here, where we had this, we can as well use size. If you run that, you get this. You can use count. If you run that, you get this. There's no difference, but it's good to note that this is the difference between these two functions. The size includes the missing values. And so when you're counting the number of rows, you count the number of you count the missing values as well when you're counting the number of rows. But when you're using the count function, it excludes the missing values. And so in the value counts method, we can use the drop NA argument to exclude the missing values. And so what that means is that, for instance, if I want to use the value count, I can say something like Titanic, then we select that. I think, was it age? Was it what? The P class. Okay, the P class. Right, then we do value underscore count. We pass in this argument that says we want to drop NA, and we can say drop NA equal to true, and that drops all the missing values for us. And once we run that, now because we don't have missing values here, you won't really notice it. So because if we look at Titanic and we look at the P class, we look at P class and we do dot shape, that's going to give us 891, and that's the number of the data set, the rows in the data set we have. So you won't really notice this. But again, the reason we are doing all of this is not so that we stick with just the Titanic. Pick any data set that you know of or that you would like to explore. Take that data set and work with it. Ask yourself a few questions. Some of these questions that we've been asking ourselves and working with, just pick those data set, pick one, pick two, just practice. I can't stress this enough. Practice and practice. The more you practice, the better you know these things. I believe that We learn by doing and we do by learning. So here's a recap for this section. Remember, aggregation statistics can be calculated on entire columns or rows. And we have established that already. I don't need to restate that again. Group by method provides the power of the split, apply, combine pattern, which I already explained. When you use group by, you split, you apply the function, and then you combine the result. Value count is a convenient shortcut to count the number of entries in each category of a variable. So if you want to count the category, you want to count each category, this is very handy for you. If you want it to be with the missing values, without the missing values, you have to categorically state it, just as you have it here. Drop any equal to true. Thank you for your time. I hope you're really learning something. And please let me know in the comment section, what other data set have you been working on? What data set do you intend to work on? Or even what data set would you like us to explore sometime later in this video series? You can leave your comment below. Thank you, and I'll see you in the next one where we talk about how to reshape the layouts of tables. Have a great time. Bye.